Hello, friends. Welcome to New Tech Dojo's new podcast, Machine Learning Myths versus Realities. With me, I have Ben. Hi, Ben.
Hey, Rashab.
So Ben is actually a chemical engineer. He's done his undergrad and postgrad in chemical engineering, but today he's in artificial intelligence. So it's actually inspiring for a lot of us who could be somewhere else and be in data science or AI or machine learning tomorrow. So Ben, you're actually the kind of an image we all, I would say, idolize, since we are not from the programming or typical computer science background, which typically a lot of people are. Uh,
Yeah.
so Ben has worked with Intel Micron. He's worked with a US-based hedge fund as an AI analyst. He's built teams for data science at a Sequoia-backed company called as HireVue. You're still associated with HireVue, Ben, right?
Yes. Yes. I'm still an advisor for them. It's pretty low touch though.
Right. And right now he's a founder promoter for the company ziff.ai. So when I looked at Ziffy, I was kind of confused. So you are an enterprise service provider for what? For image and video algorithms?
So we focus on deep learning, but we've gotten into this interesting use case where we can build models that consume all of the data.
Okay.
So we have single models that will consume video, audio, image, text to make one prediction for a customer.
And what
So a
kind
lot
of
of our custom,
algorithms do you use there?
all deep learning.
Okay. Okay. And who are your customers there? Sorry, you were saying something.
So the thing we've noticed, interacting with the market, a lot of people don't really understand the AI opportunity in the market. And I guess what I'm trying to say is what businesses need. And the
Right.
thing we've noticed interacting with businesses is they're not doing simple classifiers and regressors. They want to use all of the data that matters. So they're not just going to give you an image and have you build a model to predict a defect. They
Right.
want you to know all of this structured data or metadata associated with that image. And so that's one of the things we've had to evolve and adapt to support. And so it's really nice when you have non-technical customers that are asking for very technical solutions.
Right. And most of your customers are in which domain? Retail?
That's another interesting thing too, because a lot of VCs they want you to focus. They
Hmm.
want you to just focus on e-commerce or sales or something, like some sales support channel, call center, e-commerce. So we haven't we really see ourselves as a platform, so we haven't focused yet. So we have customers coming from e-commerce, coming from entertainment, insurance, automobile, manufacturing. So um, they're all over the place.
Interesting. I'm quite surprised how deep learning is being adopted by so many different sectors.
Yeah, and I think that's kind of a scary thing for the job market because really any position where you have a human reviewing unstructured data, image, text, audio, or video, and this just happens a lot in manufacturing. So quality inspection steps, they're very good opportunities for people like us to come in,
Right.
or anyone really to do deep learning and to do it at a superhuman level.
Right. The way I got introduced to you was actually your one of your answers in Quora. What is the weirdest thing a neural network has done? Friends, this article had 118,000 views, and you got more than 6,600 upvotes. Pretty fancy.
Yeah, I think that one of the nice things about having not doing so if I was doing formal like PhD research for AI or if I was employed, I wouldn't have the flexibility that I have now. And so there's some really fun things that we can do when it comes to AI,
Right.
just because we have the hardware and we have the talent and maybe the curiosity to go try something. So yeah, so there will definitely be some more applications that'll be maybe a little bizarre or fun to get thinking.
Right, right. Great. So I mean, we'll split up this podcast into two parts. One is myth versus reality. This is basically like consolidated like statements where which have been shooted to me at various events or YouTube comments. And the other part is how can somebody get started with machine learning or becoming a data scientist, right? So here we start with the first one. Machine learning engineers make system think exactly like humans.
Um, so that's so this kind of gets into narrow AI versus general AI. So narrow AI is doing a very, very specific task. It's um, you're looking at something and you're trying to detect a scratch.
Mm-hmm.
Is there a scratch here? Is there not a scratch here? So this can be manufacturing. And if I think right now the kind of the belief is if you have enough data and if the data quality or if the label quality is good, that you should be able to compete with a human,
Right.
if not surpass them. So we have lots of examples where we'll do much better than a human. But then you have things like automatic speech recognition, where we're just starting to kind of get to the superhuman level, but we're not quite there yet. And so when it comes to speech recognition or language comprehension, a human's going to do that much better.
Right. So the answer here is
It,
gray. I mean, for some tasks, the machine
yeah.
is like human, and for some tasks, it is still not.
Yep.
Got it. Got it.
And there have been some guidelines for that. I think Andering said tasks that take a human a few seconds to perform should be ripe for automation or superhuman machine performance. But we also see tasks that take much longer. So we have customers today where the human might take 15 minutes to do something that the computer can do in an automated fashion. And one of those examples is property appraisal. So
Right.
for me to come to a house and walk through the house and decide how much the property is worth, we have a few property appraising deep learning models that consume all of the images, all the text, and all of the structured data on a property, and they predict the price.
Wow.
And they're doing really well. I would argue that they're superhuman.
Right.
So,
Okay. So we go to number two. So only skilled data scientists can use machine learning.
so um, I think machine learning is getting easier and easier. So I feel like we're standing on the shoulders of giants, and we keep going higher and higher in this technology stack. So you can do some fantastic machine learning with a few lines of code, like less than 10 lines of code. With
Right.
some examples, less than 5 lines of code, you can do some very powerful things. So I gave a presentation a couple years ago where I showed that you can build a resume model to look at someone's digital resume and predict if they should get a job with 5 lines of code.
Wow.
And at the time, that was a big deal because people were paying hundreds of thousands of dollars to get access to solution providers that could do something similar.
Mm.
Um, so I don't think you have to be a machine learning expert or a skilled engineer to do some very interesting things with AI.
I
I
was looking at few software tools like Azure for machine learning and Alteryx for. I mean, they had few drag and drops like blocks. How we create a flowchart. You just drag and drop the
yeah
algorithm, connect to data source, connect with output, and make a feedback loop. I mean,
yeah
yeah.
I wouldn't
So maybe
I
we don't need to be a programmer for sure to master machine learning.
yeah you don't, and that's actually one of the things that we're focusing on with our company is we're trying to reduce the barrier to entry, because and we've seen this with companies like DataRobot and H2O and some of these machine learning automation platforms where before the machine learning experts felt like this was like a sacred thing that they did, that we go and we build these machine learning models, we do this tuning, we do all this stuff that's very complicated. You, software developer, can't appreciate how smart we are or how special this is, what we're doing. And then you have these companies that automate that.
Mm.
So I'm of the opinion that anything a data scientist can do eventually will be automated. And so you have AutoML, Google's AutoML. It'll do automatically build classifiers. We do something similar, and then someone just released an open source Keras AutoML equivalent where you really don't have to know anything about deep learning. You just have to know where the data is and what you want to achieve with it.
Right. Makes sense. Okay. So the verdict is a myth. Number
Yeah.
three is machine learning and artificial intelligence are one and the same thing. There's a lot of This has been highest frequency question I've been asked almost on every episode.
hmm Um, I think this is a funny one. Sometimes I get in trouble for this. So my title right now, I'm a chief AI officer. So I could be called a chief data officer, but I'm a chief AI officer. And if I'm talking to an executive or a manager, I'm going to use words like AI. If I'm talking to someone more technical, maybe I'll use words like machine learning or data science that are more specific. But the general public, they don't know what machine learning is, and they don't know what data science is, but they know what AI is. And so I know there's kind of this nested hierarchy of AI is this, and machine learning is maybe a component of that. For me, it doesn't really impact what I do besides deciding what words I'm going to use to communicate with someone. So what was the original question?
So
AI, machine learning?
are they one and the same thing?
Yeah, they are one and the same thing. So machine learning is a machine that is reviewing data and becoming smarter, and then So I guess I would see machine learning as a component within artificial intelligence.
Got it. Got it. Okay. So number four, machine learning requires some data science background or some pre-qualification to begin with.
I think for basic problems, I was about to say it doesn't, but then I'm going to go back off a little bit. So even with some of these very simple machine learning workflows, we've noticed when we present them to typical engineers, they get kind of confused at first because the whole concept of having a training set and a validation set is very different to them. It's very foreign. So if people can get past that, if they can understand you have to show the machine data and then you have to show a subset of data to prove that it worked, then I feel like anyone can do it. Anyone can do most of the AI problems out there,
Right.
like classification, regression. But then they won't be able to do anything. You're always going to have hard problems that require custom expertise. Maybe they haven't been done before, like our bachelorette ranking algorithm, where then you do kind of have to be an expert to understand how you approach that. And actually, we found a fun use case with one of our customers. They're having us predict ad spend, and normally with machine learning, you're going to train a model and you're trying to reduce the error. Right. What am I predicting, and what was the actual answer? And you're trying to get that lower and lower and lower, so you get a small error. But there are problems out there in the real world where the error is one-sided. So for a hedge fund, if I have a model that accidentally makes me too much money, I don't care. If I have a model that loses me money, then I care. And then with ad spend and advertising, if I predict that this ad spend if it ends up losing money, that's really bad. But if it accidentally is too successful, I don't care. And so then you get into these one-sided errors, and that's not something that's just out there in the wild that's generally supported. So then you have to kind of bring the expertise on, okay, how are we going to teach the machine to ignore these types of mistakes, but be very sensitive to these types?
Got it. Okay, so number five, AI engineers just develop the system once, and the system keeps on learning by itself then.
So there's a few things to this question to unpack. So one of the things that so continuous learning. Maybe before we tackle continuous learning, I'm just going to tackle the naive. So So a lot of data scientists are very naive about machine learning, shipping it into production until they've actually done it. And so once you have a model in production that's being consumed and being relied on by a business, there are all sorts of headaches that come with that. And so we talk about manning the bat phone. So you might train a model, and let's not even talk about continuous learning. I trained a model, I'm done. I'm going to give it to this customer. They're going to start consuming that model. Things might be great. They might love it for 1 month, 2 months, 3 months, and then they might call me on month 4 and they're really angry because something happened to their model, and the model didn't change. I didn't do anything different. And what we see is in the wild, when you're actually deploying models into production, you have to treat them like a manufacturing process where you might get a change on a feature coming from a vendor, or the inputs going to the model could change. Maybe the image is drifting, they have a camera, they use a different camera vendor, something happens, and the model doesn't behave appropriately. So at HireVue, we had to put in all of these process control checks, like statistical process control checks, on our models, where we would look at the model output predictions and make sure that those distributions weren't changing. So that said, doing continuous learning, yeah, that's fine. You can set something up where it's constantly learning, but now you're dealing with this nightmare of deployment. Do you do a continuous deployment? Because if you do a continuous deployment, how do you protect yourself against drift? So a lot of times you have to do a discrete deployment. And every time you deploy, you have to reference an older validation set. Or then you have to start
so somebody can do like once in 2 months or once in a quarter or something like that?
Yeah, and that this is something that we're working on right now. We actually see model stability pretty good where people might, so our customers now, they'll train a model maybe once every 6 months or once a year for an application, and then they'll be done. But they train on very large data sets. They're training on tens of millions of objects. So that generalizes well. But we are working to support more of a sprint cycle, continuous learning deployment. So every 2 weeks, you might be deploying an updated model into production. So I guess getting back to your original question, it doesn't just get smarter because it actually takes a lot of work. And it's really hard. There's lots of problems, and you can have so just like excursion or a misprocessing event in manufacturing, you can have that in AI when you're consuming it like this, and it may not be your fault. It's just the reality of the complexity of what you're doing.
Got it. And as if the more general you try to create, the more complex it gets, right? If we make it more specific, then I think the need to retrain will be less frequent.
Yeah, and the other thing we suggest too, we dealt with this at HireVue. There's really not a lot of value for you retraining if you're not bringing a lot of new data. So if I trained something on a million objects and I now have 1,000, there's really no point retraining with that 1,000. So you kind of have to get to a significant fraction. So if you're getting the other thing about reinforced learning that some people like is they don't have the labels, and so they want you to reinforce on predicted labels. So if I'm trying to predict damage, not damage, for items that get really high damage confidences, they would then be thrown into a cache and trained on assuming that they were labeled by a human.
Right. Okay.
So it's a complicated process. It's not magic yet.
Yeah. So, and now coming to the last one, which says machine learning will soon give rise to superhuman intelligence. I guess people are watching a lot of Hollywood movies.
Yeah. So I'm fascinated by this because the more I think about it, the scarier, the more scared I am. So I actually have 2 robot apocalypse posts that I've done. One of them, I'm talking about the complexity of a hive mind and kind of showing that humans lose. There's no way for you to fight against a hive mind. It's kind of a losing battle. And then I also talk about the $1 trillion war incentives that will kind of drive this to the end. So the scary thing for the general AI is if it's being enabled through kind of this capitalist war push. So you have countries like China and Russia and the US that have all been pretty active with their AI warfare research or their posturing. So in the US, we had the Maven projects that were made public, where Google and Clarify were doing deep learning on the drones, and I'm sure there's lots of others that aren't public. And then in China, they've been investing billions of dollars into their AI focus. And then Russian Putin has the quote saying, I don't remember the exact quote, but he said, "Whoever rules or whoever leads the world in AI essentially will rule the world." So if your country is the leader in AI, you have an opportunity to rule the world. Um, I think the average consensus is we could see something like the singularity in the year 2045, but I think you're going to see some very, very scary autonomous weapons before that. Um, so one of them would be drones, like
this
these
is
flying
weird.
drones.
This is weird. I mean, more weird than your Quora post, actually.
Yeah, I'll send you a link to these articles maybe to post in the show notes because they're. I think when you really think about it, so if this is what you do every day is AI, and you really think about how you would fulfill a contract, like if I'm not saying our company would do this, but if we were bidding on $1 billion contract, these are the types of selling points that I would push for. And when you realize what I'm pushing for, you realize that's very, very scary. And so one of the things that comes up in the article is, so these humanoid robots, have you seen the Boston Dynamics robot that does the backflip and it's walking around?
I saw a few videos.
It,
They were made by a Japanese
it's,
company, right?
so Boston Dynamics is a US company. I know Japan's doing a lot with robotics, but they have a humanoid robot walking on two legs and it's walking through the forest and it's rough terrain. But then they show a video where this robot is doing parkour, so it's jumping onto boxes, and then it actually jumps and spins, and then does a backflip.
Wow.
So the humanoid robot does a standing backflip and lands on its feet. And I'm convinced in the next 10 years, you're going to have a humanoid robot that can outrun a human. So the fastest human in the world, you'll have a humanoid robot that will outrun that human. And then it just becomes a power consumption issue. But the thing, so you have general AI, and you're going to have so much disruption that happens before general AI that general AI is not really the scary thing right now. It's autonomous warfare and then massive job disruption. So I think before you see general AI, you're going to have autonomous weapons that kill, and you're going to have riots and protests over job loss from AI. And you could even make the argument that you could have a human extinction event before we see general AI because of these autonomous, these autonomous drones.
You're making a really encouraging point why people should join data science today rather than tomorrow. I mean, better be on this side if you're going to rule the world. Better be on this side.
Well, the thing I like about AI is it kind of blows open all of these new ethical discussions that we haven't had to have before. So at HireVue, we dealt with hiring, and AI will actually naturally include bias. So if you're training a model to predict if someone should get a job, and you just look at resumes and you predict outcomes, your model is going to be sexist, racist. It's going to have bias, and that's just a given. And so it actually takes a lot of effort to block bias learning within AI. So HireVue, our data science team, we spent several years working on it, and we got to a really good place where we could actually take a training set that had racism already, and we could train a model and block the bias transfer. But you'll keep seeing examples like this of ethics, AI ethics, where people are, and there's a popular show here called Black Mirror. So a lot of people use the Black Mirror hashtag.
Yeah, the Netflix show.
Yeah, the Netflix show, and I've had people use the Black Mirror hashtag and kind of tag me because of some of the HireVue work that we've done. Um, and one of the times I actually got kind of frustrated that because the idea of a computer watching your video interview and deciding if you should get a job, for some people, they kind of react to that and they say, hell no, no way, that can't
Mm,
happen. I don't like that.
mm,
But what they don't realize is the human process is much worse. So you getting a job through the human process, you're dealing with a similarity bias, a likability bias, racism, and then also a big random. A lot of people get discouraged. They'll go and they'll apply to Google or Facebook, these different companies. And they won't get a job,
correct.
and they'll think it reflects poorly on them. The thing they don't realize is there is a huge luck component
Mm,
that you not getting a job at Google could literally be you applied 1 week too late.
mm,
Because the thing with these jobs is they come in waves. So there's job openings that people are opening up. So for me, I've hired data scientists. So I'll post a job rec. I'll get all of these applicants. I'll start looking through the applicants and trying to find the ones I like. But then usually what happens, especially with these positions, I'm really busy. I don't have time to be hiring, but I have to hire. And so I procrastinate the position. And so people are still coming in. They're still interviewing. They're still applying.
mm,
I'm not looking at them. I'm not looking at any of them. And because I can't, I don't have time. I've already reviewed the candidates, and I feel like I found someone I'm going to hire. I make the hiring decision, and everyone else gets a rejection.
yeah.
But there could have been someone coming through that was fantastic. And so AI really helps with that. So AI accelerates the right talent to the top, and it prevents the subjectivity that humans bring with hiring. So I have another article I wrote called Racism Under Every Rock, where I used AI to show how terrible the human process is.
Mm,
So I took human data and I used deep learning to show that there's racism and sexism and beauty bias
mm.
on the human data.
You remind me of this
So,
book called Everybody Lies, where they are
oh
showing
yeah.
how weird things are captured by data, and the corporates are using, the organizations are using it over us.
Hmm.
So interesting. So yeah, so
Yeah.
coming to the second part, how can, if somebody is starting right now in the middle of, say, a statistics or a programming learning course, how can somebody become a data scientist tomorrow? Does he need to go to a specific university course? Can he learn this on his own? Which resources would you recommend?
Yeah. Um, so I'll kind of take this to the extreme and say that there's no university, maybe outside of Stanford or like some of the best, that are really equipped to bridge the gap between what industry needs and what the universities know.
Right.
And so I would say that committing to a university program, it really only helps with your foundation. There's no university program that will complete you completely to be ready for a job in data science. So for me, I never took a university course around machine learning or anything data science related. I was self-taught, but and today actually we really don't engage with local universities for capstone projects and internships because we notice there's way too big of a gap between what those students know and what industry needs. And a lot of the college programs we look at, the students are only exposed to what we call hello world examples. So like for deep learning, they know MNIST, or like the use cases they have are so simple, or natural language processing, they can build a sentiment model from Twitter, but they haven't jumped into some of the neural network clustering approaches like GloVec and Word2Vec, or they haven't jumped into lemmatization and stemming, and there's just so much to learn. And I think in the university programs, there's a lot of waste. There's a lot of waste that you learn. For people, if they're passionate, I would just go get books, get some online. There's some really good online courses. There's even great courses on YouTube,
Mm,
just like mini courses. But I think the best thing to do is buy a book and just tear the book apart and go through it. And then the other recommendation I would say is if you're getting slowed down in the book on theory, like any
mm,
mathematical theory,
right.
I'd just go past it. Um, so if you have some confusion or a question around, well, this math is confusing, I don't get this math, I would go to YouTube and search a tutorial on gradient boosted regression or logistic regression, and you'll find a 3-minute video on YouTube that will teach you completely. You'll just get it. But if you try to like understand the matrix math, it's not useful. I actually discourage people from reading white papers until they're actually in the role and they know what they're doing.
Right. Interesting.
So yeah, that's the great thing about data science is literally anyone can go and be very successful with it. So I need to fill up my so I've hired PhD physicists for data science, which might be discouraging for people, but I've also hired college dropouts. So I've hired one college dropout. So hopefully I can kind of fill in the middle. And they've all turned out to be great data scientists. So
all right, excellent. Okay, thanks, Ben. People, you can follow Ben on Quora. I mean, he's pretty active these days, and you can follow him on Twitter too. Both the links are there in the bottom of the video in the description. Ben, thank you so much for taking out time and enlightening us. Really appreciate it.
Yeah, thanks, Rashab, and I encourage everyone to subscribe to Rashab's channel. It seems like you're getting good content that you've thought through, and I'll send you some of those links to the robot apocalypse posts, and then some of the ethical stuff that you can include as well if you like.
Excellent. Okay. Thanks, Ben. Have a great day. Bye-bye.
Okay. Okay.